Hello and welcome to this learning video. As you know that in the last learning video we have started with the topic application of Fourier transform to integral equation. And under this topic we have solved one example, and here we are back with the another examples on this topic. Okay, so this example says solve the integral equation this and hence evaluate. So actually we have to find out how many results? 2, that's correct. And so first of all we are going to find out the solution of this, and then we will look for this result. Okay, so if you remember in the last learning video, and in the end I have already told you the working rule of this, not written but orally I have just stated this. So what you need to do in such problems, you just need to take this function to be some function, okay, this given equation to be some function, and let me write here, this is a function of alpha, earlier it was a function of lambda. So that g of alpha is equal to integration 0 to infinity f of x into cos alpha x dx is equal to 1 minus alpha 0 for 0 less than equal to alpha less than equal to 1, and this is for alpha greater than 1. And what is parameter here? Here alpha is your parameter, right? Therefore, and say this is, you can say this is to be equation number 1. Okay, now if you can look at this integral equation, this would be this would be a Fourier transform. If I multiply this Fourier cosine transform, if I multiply this by under root 2 pi. Okay, so what I am going to do here is just gonna multiply this entire equation 1 by under root 2 pi. So I will be getting then under root 2 by pi g of alpha is equal to under root 2 by pi integration 0 to infinity f of x into cos alpha x dx is equal to, when I multiply this also, so I will be getting under root 2 by pi into 1 minus alpha 0 less than equal to alpha less than equal to 1, 0 into anything 0 for alpha greater than 1. Simple. Now as you can see, this is my definition of Fourier cosine, right? So you can just write here but under root 2 by pi integration 0 to infinity f of x into cos alpha x dx is my Fourier cosine. Okay, fc bar of alpha, because here the parameter is alpha. Okay, so I just replace this by this, and hence I can write, and hence under root 2 by pi, okay, and hence fc bar of alpha is equal to this under root 2 by pi into 1 minus alpha 0 less than equal to alpha less than equal to 1, and here we have 0 for alpha greater than 1. Simple. Now once you have got this, now the next step you can able to tell me, and once you are getting Fourier cosine, okay, then you just need to take Fourier inverse cosine transform. Okay, why? Because my objective is to get the solution of this integral equation, meaning thereby I need to find out this unknown function, right? So what I need to do now, I just need to apply the Fourier inverse Fourier cosine transform. So you can write here, taking inverse of Fourier cosine transform taking inverse Fourier cosine transform, we get what we get. You can just write Fourier inverse Fourier cosine transform of C bar of alpha is equal to. Now as you can see here we have this to be what? This to be in the interval 0 to 1 and greater than 1. So I need to break. So first of all I will write it as like under root 2 by pi integration 0 to infinity fc bar of alpha into cos alpha x d alpha. Okay, now what I need to do is just bifurcate this interval from 0 to infinity as 0 to 1 and 1 to infinity. Okay, now so this is nothing but f of x, right? So because Fourier and Fourier cosine inverse both cancels each other and we get the function f of x is equal to under root 2 by pi integration. Now I am breaking this as 0 to 1 fc bar of alpha into cos alpha x d alpha plus integral 1 to infinity fc bar of alpha into cos alpha x d alpha. Okay, and I have written here the function, I just rubbed it. So in 0 to 1 we have under root 2 pi. So this is 2 by pi. The value of this is root 2 by pi into 1 minus alpha into cos alpha x dx plus integral 1 to infinity. The value for in the interval 1 onwards we have it to be 0 cos alpha x d alpha. Simple. Now we can just take this one out, that is f of x is equal to, this is 0, so I can write I can just take this 2 by pi common. So this is root get cancelled, integration 0 to 1 minus alpha into cos alpha x dx. Now I am going to make use of the integration by parts, because we have the algebraic function over here and then we have any function, so we can apply the smart formula for this integration by parts. So you can just write it as 2 by pi and apply here integration by parts. Okay, so what is first function? Integration of second. Integration of cos is sine alpha x upon sine alpha x upon x. Okay, here integrating with respect to alpha minus derivative of first. Derivative of this with respect to alpha is 0 minus 1 and again integration of this. So what is integration of this? Integration of sine is minus cos alpha x. Already x is there, one more x would be there, x into x. Okay, and there are limit from 0 to 1. 0 to 1. Simple. Just one line. Integration by parts in one line. Okay. So this is 2 by pi. Now apply the upper limit minus lower limit. In place of alpha put 1 and then put 0. So this is 1 minus 1 0. So upper limit 0. Then 1 minus 0 is 1. Sine 0 is 0. So upper limit minus lower limit 0. Minus into minus plus 1 by x square common, put alpha is equal to 1, so this is cos alpha minus cos 0. Simple. Now this is 2 by pi into, now you can give this minus sign over here and you can write it as like 1 by x square cos alpha minus cos alpha minus minus plus, cos 0 is 1. Okay, so this is my f of x. If you want, we can write it nicely and we'll pack it in a box. So f of x is equal to 2 by pi into x square 1 minus cos alpha. This is my f of x. Now after finding, so this is just the first part. This f of x is equal to 2 by pi x square 1 minus cos alpha is nothing but the solution of this function. Okay, it should not be alpha, it should not be alpha, alpha is 1, it should be x, sorry, because we have integrated with respect to d alpha, this should be x. Yeah. Okay, so 2 by pi x square 1 minus cos x. So this is my solution of this integral function. Now I have to find out the second part also. So for the second part, let me put this value in equation 1 that we have already written. So do you remember what is my equation number 1? Yes. What is my equation 1? Putting this value of f of x in equation 1, we get, so if you remember, my equation 1 was 2 by pi integration 0 to infinity f of x into cos alpha x dx is equal to, what was that, under root 2 by pi, it is just 1 minus alpha. Okay, 1 minus alpha, 0 less than equal to alpha less than equal to 1, and it is 0 for alpha greater than 1. Let me check this equation 1. Okay. So this was my equation 1. Okay, 2 by pi. We can just check. If it is 2 by pi, then it must be under root 2 by pi. Just a moment. No, it is not like that. 2 by pi integration 0 to infinity. My equation 1 was this is equal to this, then under root 2 pi. Okay. This was my equation 1, given equation. This is equal to this. Okay, that was my given equation. Sorry. So this is my given equation. Now I can substitute the value over here. This is integration 0 to infinity. What is my f of x? Just need to substitute this 2 by pi x square into cos alpha x, sorry, this is 1 minus cos x into cos alpha x dx is equal to 1 minus alpha this. Okay, now what I can do is I can just take this 2 by pi outside. So this is 1 by x square 2 by pi. Okay, now what I want in the question, in the solution, value of this. Okay, I don't need this cos. So what I can do is I can just substitute alpha equal to 0, because in the answer I don't see any parameter. So this is the term with the parameter alpha. So I need to remove the parameter alpha. So what I can do is put alpha is equal to 0. We get, the moment we put alpha is equal to 0, The moment we put alpha is equal to 0, so this would be just 2 by pi integration 0 to infinity 1 by x square. Okay, you can write 1 minus cos x upon x square into, this is cos alpha is 0, so this is cos 0 dx is equal to, now alpha is equal to 0. Alpha is equal to 0 comes under this, so when I substitute alpha is equal to 0, so I will be getting it to be 1, right? So this implies 2 by pi integration 0 to infinity, what is cos 0? 1, no need to write, so I remain with this 1 minus cos x upon x square dx is equal to 1, since cos 0 is 1. Now do you remember the formula for 1 minus cos theta? What is the formula for this? 1 minus cos theta is 2 sine square theta by 2, is it? So I'm going to make use of this formula now. So 2 by pi, I will take it here. So I remain with integral 0 to infinity. This is 2 according to formula sine square x by 2 upon x square dx is equal to, this 2 by pi will go to the right and it becomes pi by 2. Okay. Now continue this. So you will be getting it to be this, but we need sine t. Okay, it is not like sine square x by 2 or something like that. So I need to do substitution over here. So put x by 2 is equal to t. This implies dx by 2 is equal to dt. That is dx is equal to 2 dt. Simple. So dx is equal to 2 dt, and when x is equal to 0, t equal to 0, when x is equal to infinity, t equal to infinity. So limits are unchanged. Okay. So limit of x, limit of t. So limit of x are 0 and infinity, so as limit of t 0 and infinity. Okay, limits are unchanged. So now my problem becomes integration 0 to infinity 2 into sine square x by 2 is t upon x square. So what is x square? X by 2 is t, so x is 2t. So this is 2t whole square. dx is 2 dt is equal to pi by 2. So this is nothing but integration 0 to infinity 2 2s are 4 sine square t dt upon 4t square is equal to pi by 2. This get cancelled and we got with the value that we have to find out, and that is integration 0 to infinity sine square t upon t square dt is equal to pi by 2. Okay, so this is the result we wanted to get, and the solution of course of the integral equation that we have already found out. So I hope this is clear to you. So thank you for watching this learning video and have a good day. Thank you.